Hello students, in this video we have first one of the exercise of chapter 5. There are a few questions here. We'll deal with each one by one. Very first is, a vector needs three quantities for its specification. Name three independent quantities conventionally used to specify the Earth's magnetic field. Now the way we need three vectors x, y, z or I cap, j cap, k cap to locate any particle in three-dimensional space, how do we know or how do we specify magnetic field at any place on the Earth? So the answer is the quantities which we need are magnetic declination, magnetic deep angle, and horizontal component of Earth's magnetic field. If you have these three quantities known, you can estimate magnetic field at any place, at any given place on the Earth. So the three quantities are declination angle, deep angle, and horizontal component of Earth's magnetic field. The second question, the angle of deep at a location in southern India is 18 degree. Would you expect a greater or smaller deep angle in Britain? Now, to answer this question, let us first understand the situation. What do we mean by deep angle and how it changes or why it changes? So, consider that we have a very gigantic magnet. Say north is here and south is here, and so the field lines are going like this. Okay, and now we are having our tiny magnet somewhere suspended, say at this point. Now obviously the magnet, freely suspended magnet, knows magnetic field line and nothing else, and hence it will settle itself in this manner, and then we say that this angle is the deep angle. The angle subtended by the magnet and the horizontal is deep angle. So here is the deep angle, right? And how the deep angle changes, suppose instead of this particular point, suppose if we choose to suspend our magnet at this point, what will happen in this case? The magnetic field line and horizontal, they are making zero angle, so we say that deep angle at this point is zero. And what if we go at some other point, say here? So at this point our magnet will be like this, okay, and hence the deep angle is this is the deep angle. So deep angle changes from point to point. Now if we consider the Earth, say this is the Earth, and inside the Earth we have a magnet, gigantic magnet, which we assume is like this, with South Pole near geographic north and North Pole near geographic south. Okay, and let this be the geographic axis. Now somewhere here we have India and somewhere here we have Britain. So as we move, see, as we move from one point to another point, as we go from this point to other point to next point close to poles, deep angle will definitely change, and change will be like this. Okay, so what happens as you go from equator to the pole? As you go from equator to pole, the deep angle increases, and as Britain is close to magnetic south pole, deep angle there should be more than that near the equator. India is close to equator, so if angle near India is 18 degree, then as you go towards magnetic south or magnetic north pole, deep angle should increase. Next question. If you made a map of magnetic field lines at Melbourne in Australia, would the lines seem to go into the ground or come out of the ground? So as I said that somewhere here we have magnetic north pole, okay, and hence magnetic field lines will come out. If you are somewhere in Canada where we have magnetic south pole, the field lines uh, will be going inside. Next, in which direction would a compass free to move in vertical plane point to if located right on the geomagnetic north or south pole? Consider this to be pole. So again, suppose we have a gigantic magnet, and say this is the north pole of the magnet. This is the north pole, right? And on this magnet, say we are standing on the north pole, and we have a tiny magnet freely suspended in our hand. Okay, what will happen now? The tendency of this magnet. What is the tendency of this magnet? If this is the north pole and if this is the south pole, the tendency of this magnet is to be vertical, isn't it? With south pole down and north pole here. If it is free to move, what the magnet will do? It will become vertical with theta 90 degrees. So when you are at magnetic pole, may it be south or north pole, the deep angle will be 90 degree. But this is the case where you have magnet suspended with some thread. If you are talking about magnetic needle compass, what happens in that case? In that case, suppose if this is your north pole, very gigantic magnet and its north pole, and now you have magnetic needle which is inside this box. Now this needle also wants to be vertical, but it has not that freedom. It has freedom of rotating anywhere along the dial, but it cannot become vertical like this, which it wants to do. And so what this needle will do? What this needle will do? You put it anywhere, it will show any reading on this dial. It makes no difference to the needle. Okay, and then when you are on magnetic north pole or south pole, you should not rely on the angle shown by magnetic needle. Okay, because it wants to be perpendicular, it cannot, and so any other reading makes no difference to it. Next, the Earth's field, it is claimed, roughly approximates the field due to a dipole of magnetic moment 8 into 10 raised to 22 joule per Tesla located at its center. Check the order of magnitude of this number in some way. So how do we find out Earth's magnetic field? So we have formula on equator. If we consider B is mu 0 by 4 pi m by r cube. Okay, so you have this number 8 into 10 raised to 22, that is the dipole moment m. Okay, and we can find out Earth's radius, and then you can estimate how much is the magnetic field. So substitute values and you can find out, and try to express it in terms of Gauss. This formula will give you answer in terms of Tesla. Convert it into Gauss. Lastly, geologists claim that besides the main magnetic north-south, there are several local poles on Earth's surface oriented in different directions. How is such thing possible at all? Now, though we consider Earth to be like this, where you have gigantic magnet inside, but this is mainly due to large mineral deposition at core and because of Earth's rotational motion. Now, suppose if you have large mineral deposition somewhere here or here or here, it is very much possible that this part or this part or this part is magnetized more as compared to the nearby other region, and then it is very much possible that you may have local north-south pole here or here or here. Okay, so apart from the larger magnetic north pole and south pole, we have tiny north pole south pole all over the not all over but at many places on Earth's surface. So that is first exercise problem of chapter 5. I hope you could understand. Thank you.